Okay, so here's another practice sheet. Just a lot of practice so that we can get good. Practice makes perfect. Okay, surface area practice. Let's just do one or two problems together. As written here, make sure to remember to use your star chart. So, number one, a cereal manufacturer is designing a new cereal box to try and cut costs. They felt their old design took too much cardboard to build. They believe their new design, being taller and thinner, will use less cardboard. Determine which cereal box design will take less cardboard to build. So we're looking at cardboard. That means we're building the outside, meaning we're looking at surface area. And since the cardboard has to go all around the box so it doesn't spill, we're actually going to look at total surface area. Let me write that here. Total surface area. Okay, so old box is on the left, the new box design is on the right. We're looking at total surface area. So, first things first, I need my formula. I go to my trusty reference sheet. Total surface area of a box. So a box is a kind of prism. So surface area, we're looking at prism. And we're not looking at lateral, we're looking at total. pH plus 2b. Let's write that down. pH plus 2b. Same thing over here. Remember, you should know what P stands for. That's your perimeter of your base. H is your height. B is your area of your base. So let's do the old box. And let's say the bases are the top and the bottom. So here's one base, and you can't quite see it, so let me draw a dotted line in the back. Kind of invisible, but your other base is at the bottom here. So if I were to lay that out flat as a rectangle, I got 36.5 centimeters here, 9 centimeters over here. That means this side is also 9, this side is also 36.5. For my perimeter, I'm just going to add those all up. 9 plus 9 plus 36.5 plus 36.5. And I'm going to use my calculator. I got 91 centimeters. Double check me. Alright. That's my perimeter, P. My height is my distance from my bases. So this distance here from the purple base to the other one, 53 centimeters. That's 53. And capital B is the area of the base. Let me just do it down here. Area of the base. Again, that side is 9, that side is 36.5. For a rectangle, it's just base times height. So 9 times 36.5. I got 328.5. Alright, those are all my variables, all my ingredients. I'm going to put them together. pH plus 2b. Perimeter is 9. Height is 53. Oops. 53 plus 2b, so b is 328.5. Maybe I should write actually surface area S equals. Okay, put that all together. 91 times 53 plus 2 times 328.5. And here's how much cardboard we're going to need for this box. 5,480 square centimeters. Double check me on that. See if I got it right. Alright, the new box, we're going to do the same thing, but with the new dimensions. So, we still need the perimeter. Let's look over here. Here's my new base up here and down here. Okay, so that rectangle at the bottom is 20.5 and 6.5. So that means that side is 20.5, that side is 6.5. Perimeter, all the way around, we're just going to add 6.5 plus 6.5 plus 20.5 plus 20.5. Alright, double check me. I believe that'll be 54 centimeters. Okay, height goes from base to base. Okay, that's 74. And capital B, area of the base, we got a 6.5 by 20.5 rectangle. So that's going to be base times height, 6.5, base times height, 6.5 times 20.5. I got 133.25. Alright, got all the variables. Just going to plug it in. Our surface area S is going to be my perimeter, 54, times my height. That'll give me my lateral surface area, but I'm looking for total surface area. So I'm going to add two of those bases, 133.25 each. And put it into my trusty calculator. 54 times 74 plus 2 times 133.25. And here's what I got. 4262.5 centimeters squared. So it might feel like a lot, but just make sure you keep your work organized so that you don't mess up. Here I'm doing different colors. I mean, you don't have to do different colors, but just make sure you know which part is going to where. I got my P, my H, my B. And at the end, we compare these two. Here's the old box, here's the new box. Which one takes more cardboard? Well, it's the one that has more surface area. So 5,000 is more than 4,000, so this one is definitely more. So then the question is, did we save any cardboard? Yes, we did. This one is going to take less cardboard if we do this design. Alright, in real life, you would also want to check to see if they can hold the same amount of cereal inside. And remember, the space inside of a box will be the volume, not the surface area. So these other problems are going to look at things including volume as well. So just double check. For example, here when it says determine the amount of truckloads of grain required to fill an empty silo. When we're filling something, that's going to be a volume. So here you would use a volume formula. That's why we had a little review on volume in our warm-up. Okay, same thing over here, volume and surface area. Just make sure to do both of those, use the correct formulas, and some more practice problems for you. So work through these problems, double check your answers with me. I should have a key, and if you are able to do these, you should be pretty good, feeling pretty good for the test hopefully. But we'll have a review next week as well. Okay, that's it for this video. Make sure to do those practice problems. Hope you learned something, and remember to think win-win.